Hello, friends. Welcome to Edureka. This is Ishant, and today's session we're gonna cover object-oriented programming structure in Java. So let's begin and see what and all we are going to cover for the day. We'll see what is object-oriented programming, how is it different from the procedural approach, what are the various fundamentals available in object-oriented programming. That's like the four main pillars: inheritance, abstraction, polymorphism, and encapsulation. So we'll begin with object-oriented programming. So guys, this is one of the software design methodologies that how we're gonna write a software solution in the industry, and it's followed widely. So what is this object-oriented programming? It's a methodology or a paradigm using which we can design our software solutions. Now there are two major words which you need to focus on. The first one is object and the second one is class. Now, why object comes first and class later? Because of the term itself, object oriented, not class oriented. So we'll discuss on these objects and classes. So guys, object is a real world entity. When I say a real world entity, what does it mean? It means anything which you can see, touch, feel is an object. For example, laptop, mobile phone, chair, table, fan, anything. Even you and me are the objects. So every object will have some state and behavior. What is a class? Class is a blueprint, or I can say it's a drawing of an object. So how an object will look like, how object is going to be represented, that we can do by having this guy called class. So let's say there is a class called dog, which is a representation how a dog will look like. So we will have a representation in two of the ways. The first one is properties and the second one is behavior. Now, properties are also referred to as attributes. For example, what is the weight, what is the age, what is the size, color, breed. So these are the properties. I can even say that they are the attributes which are linked to your object. Behavior goes like eat, sleep, run, bark, etc. and etc. So let's say a nose over here is used for having a process called breathing or respiration. Respiration is a behavior. So we have object with the properties and behavior. So object will have properties, object will have behavior, and these properties and behavior will be written in the class to describe the object. So having object oriented programming approach, we can have different type of objects. So their properties will remain same, but the value for their properties will change. Now the size, age, color and breed for all the different dog objects, it's gonna change, guys, right? So even when I talk about something like employee to a company, let's say plumber, electrician, carpenter, let's say HR, let's say software engineer. Now the different employees, they have the same details. That's like what is their employee ID, what is their name, what is their age, what is their phone, but the data for these properties will be different. Now same way, the sleep pattern would be different for different people, right? So this is what we are going to understand, that different objects, they will have the properties, same properties, but with the different values, right? So I can say an object is a container which is containing properties and behavior both. Now how we are different from procedural approach, the way we used to write programs in C. So how is it different, right? Let's have some comparisons coming in here. So object oriented programming is a bottom to up approach. What does this mean? This means you think of an object first and then you start coding. You think of data first. Top down approach is like where you just start writing the program. We modularize our program into objects, whereas in procedural approach we need to write functions. For security, we have access modifiers. We got default, private, public, protected, but there we have no access modifiers. Objects can move and communicate with each other through member functions, but whereas in functions we don't have objects, so data is just moving freely. So having access modifiers, our software solution can be designed with much more security, right, as compared to procedural approach. And lastly, we have features like overloading, overriding, inheritance, and many other features which object oriented programming will give us. so that we can very easily design our softwares, which procedural programming will not do that. Now, there are four major fundamentals when it comes to object-oriented programming structure. Guys, we got encapsulation, abstraction, polymorphism, and inheritance. So these are the four major building blocks of any object-oriented programming language, right? So we even call them the pillars for the OOPS. So we'll discuss them one by one. To begin with, what is inheritance? So guys, inheritance is where the property of an object will be acquired by the other object. We'll have a relationship called is a relationship. So it's a parent-child relationship. So having this relationship, let's say animal is the parent, mammals, reptiles, amphibians, and birds, they are the children. So this is a relationship. Bird, reptile, mammal is an animal, right? So that is how we are relating them. We also call this concept as generalization, because here we are generalizing so many different types as one single type, right? So we call animal as super or the parent class, whereas mammals, reptiles, amphibians, birds, they are known as sub or the child classes. So guys, let us have one example on inheritance, and thereafter let's try to code it. So consider that there is an object structure called product. So product is going to have a product ID, product will have a name, product will have a price. So these are few of the attributes associated with the product, right? Now I'm taking this use case. Let's say we are going to develop an e-commerce solution. For an e-commerce solution, now there will be a product which can be an LED TV. So LED TV will extend the product, right? So what is the benefit of extending LED TV from product? So you'll get all these attributes in the LED TV as well, right? So we just need to write additional parameters. So we will come here and say what is the brand, what can be the technology for LED TV, and any other attributes if you want to have. We can have a mobile which can extend the product. So we can have RAM, what is the OS, what is the SD card size, and many more attributes. So extension is what is called inheritance. So if we don't have extension, so how the things will work, let's see that. With no extension, we need to rewrite a similar code snippet again and again. So you see, PID, name, price, brand, technology is the data associated with LED TV. Same is with the mobile. So PID, name, price, they are the common attributes. So when we know that we have some common attributes or common properties which will be reused again and again, this is like repeating the code again and again. Whereas when we are coming up with this structure here, so we are reusing the similar code again and again. You have product as one guy and you now keep on reusing it again and again. So let's try to come up and write one small program here and understand this example. So I'm going to say a new Java project. So we are using Eclipse as an ID. So you can use IntelliJ, JDeveloper. So whatever you want to use, you can use that. Let's say a new Java project. I'm going to say oops. So in this object-oriented programming structure on the SRC, I'm going to do a right click and say a new class. Now this new class over here, let us name it inheritance app with the main method. So I'm going to write a package. Let's say co.edureka. So this package name co.edureka contains inheritance app with the main method, right? So we know what is main. Main is executed by JVM, right? When my program will run. Now let's come here and write this class as product. And I'm going to write one constructor here which says CISO product object constructed. And thereafter let's have some attributes. We got product ID, what is the name, and let's say what is the price. So we can even have more attributes, but I got these many details. So I'm going to write methods now. So this is constructor, the default one. So the methods, I'll say void, let's say set product details, where I will say, let's take three inputs, PID, name, and price. So I'm gonna say this dot PID is PID, this dot name is name, and this dot price is price. So we call this guy as a method which is setting the details into the product object. I can even say to write data in product object, we have this method. We also call the methods as behavior, and attributes are also referred to as state. Same way, I'll have show product details, where I will come and say CISO, let's say plus product. Just give me a moment. All right. So I'm gonna say product ID this, and thereafter I'll just have this coming in. Now I will say CISO name a backslash T plus the name. The next way we have price a backslash T and the price. So this is the method which will read the data, right? So to read data from product object. So we call this structure, this class product is textual representation, how an object will look like in the memory, right? You need to understand that this PID name price, they do not belong to the class, they belong to object. So whatever we write in class is in actual property of object as we are describing the object, right? So using class, you are textually describing the object. So PID name price, they do not belong to class. Constructor, the methods, they belong to the object. So if you want something to be property of class, if you want anything which should belong to class, make it static, right? So this is what you need to do. Now coming here, guys, let us create the product object. So create an object. What object? I want product object. Let's say product is a new product. So remember, this statement is an object construction statement, but product is not an object. It's a reference variable which holds the hash code of the object in hexadecimal notation. So what does this mean? This means that if I will say product is plus product, so when you run this code here as Java application, you will get to have a product object constructed, and this guy reference variable is giving you this 7852E922. So we get 7852E922 as a hash code. Now this might vary from system to system, right? So we say product is a reference variable, right? So product is a reference variable, not an object. It is pointing to the object which is created in the memory in the heap. So next is writing data in object. So I will say product dot set the product details. Let's say product ID is 101. Let's say name is iPhone X. Let's say the price is 70,000. So this is the data within the object which we have wrote, and now let's say reading data from object, you will say product dot show the product details. When you run this code here, let me comment out this structure here, and here after writing the data, I'm just gonna put up this CISO statement. data written in product object. So just to show this, so we got product object constructed and then data written in product object, and this is data with respect to your product object. So this is how we get to see data within the object, write and read operations. Very basic structure of an object. Now we can even write the data directly. Coming here, let's write the data directly. So I can say product dot PID. Let me create another object. So I'm gonna say a product. This time let's say this as product 1 is a new product. Or let's say this is a product 2. This guy is product 1. And here I'll say product 2 dot PID is 201. Product 2 dot name is Nike shoes. Product 2 dot price is, let's say, 5,000. So this is writing the data directly. Sorry, my bad. So this is integer. So you'll say product 2 dot show the product details. So just gonna do an empty print line here for the correct output. So what you see is product object constructed. We are not writing the data using any method. We are writing the data directly, and you see the data read operation happening again. So if you don't want the data to be written directly, you can make the attributes go as private. So having your attributes as private, so you are limiting the user not to write the data directly. You see, you are now getting an error here. So I'm not gonna make everything private. Let's say the product ID is private. So when you have any attribute marked as private, you will not be able to access it. So this is an error now, since attribute marked as private cannot be accessed. You cannot access an attribute which is marked as private. So what we will do now, so we can have an indirect way to access PID. We can create a method which is set the PID. You take integer as input and you say this dot PID is PID. So guys, when I'm using this, so this means reference to the current object. So this means reference to current object. So the left hand side PID belongs to object, right hand side PID belongs to the method set PID. Okay, so LHS belongs to the object and RHS belongs to method. So we can similarly say int get PID, which returns back the PID. So when you say set PID and get PID, what does it mean? So these are the special methods. We call them setters and getters. Setter and getter is required when you have your attribute marked as private. So you have some indirect way of capturing these details in your object. So now I can come here and say product 2 dot set the PID as 201. Now this is going to work for us. So I think the basic product object structure is clear to everyone. Now moving ahead into our use case where we are going to extend the product, right? So let us take one example of mobile and extend the product. Now I'm gonna say a class called mobile where it extends product. So this is known as a relation where we say mobile is a product, and here mobile is child and product is parent. So what I'll do is I'll create a mobile constructor and say a CISO mobile object constructed, right? So this is how we are going to deal with the object. Now let us comment out this code snippet in the main. So instead of having the direct product object, I'm going to write a mobile object now. So I'll say a mobile is a new mobile. Now whenever I am requesting for the mobile object, right? So we are requesting to get mobile object constructed. So this is what we are doing here. Now, when you write this instruction, what you see is before your mobile object is constructed, product object is getting constructed. So it's like parent object is constructed before the object of child, right? So what is the behavior here? So product object gets constructed before the mobile object. So as a rule of inheritance, it is like firstly you get the parent object constructed and then the mobile object constructed. So guys, I hope this is clear, right? So what is happening here? We have parent object constructed before the mobile object, as this becomes the rule to inheritance, and we say this is object to object. Now you will be glad to see that everything, whatever product had, will be acquired in mobile, right? So we can come here and we can say mobile dot set the product details. Mention the PID, let's say 301. Mention the name, let's say iPhone X. Mention the price, let's say 70,000. And then you say mobile dot show the product details. When you run this code, you get to see that product object constructed, mobile object constructed, data written in the product object, and you see the details flowing for you. So guys, I hope this is clear, right? So whatever you had in the parent, you got in the child, right? So we have the things coming up for the child, and we can very easily access those things. Now, this product over here, we can have something like, let's say, string. What is the OS? Int. What is the RAM? And int. What is the size of SD card, right? So let's say SD card size. Now, these are additional attributes of mobile other than the product. So these are the additional attributes. Now what I'm gonna do is I'm going to have this guy over here called set product details. Let's do a copy here and let's try to do a paste here. Now I'm going to say string OS, int RAM, and int SD card size. So here I'll say this dot OS is OS, this dot RAM is RAM, and lastly this dot SD card size is SD card size. You see, PID is not accessible. We are getting an error here. It says it's not visible because it's marked as private. So private is not inherited and visible into the child. All right. I'm gonna make this PID as default. So we'll talk about the access modifiers later, but we are focused on understanding the oops here. Now we actually have this same method name set product details, right? So we have redefined the same method from the parent into the child with different inputs. So we got two methods in the child. So we have now two methods in the child, one from parent and one of child, right? So both are different, as in based on inputs, right? Even though name is same, they are different based on the inputs. So whatsoever belongs to the parent, that is inherited into the child, and now in the child we have the same method coming up again. Why we did this? Because we wanted to set the data for the additional attributes. So this is known as method overloading. Same method name with different inputs. So what I can do now is, why to access the parent's method here, I can have my own method mobile dot set the product details with the PID, let's say 301, name, let's say iPhone X, price, let's say 70,000, OS, let's say iOS, RAM, let's say 4, SD card size, let's say 128. And thereafter, I'm gonna say mobile dot show the product details. Now, when you run this code, guys, what we see is it says data written in product object. So what I can do is I can just manipulate this and I can say data written in mobile object. When you run this code, you see data written in the mobile object, but whatever you are reading is the one which was inherited from the parent. So this read method show product details is inherited from the parent and that is being used here. So hence we cannot see more than 3 details. I'll redefine this method as well. So let's redefine show product details as well. But here we have same inputs, two methods, one from parent, one in child, and we have same signatures. When I say same signatures, it means they have same input details. So what I'll do is I'll extend the data here. So we'll have OS, we'll have RAM, and we'll have SD card. So we'll have this OS, RAM, and SD card size. Now what you will observe is that when the show product details will be executed, so we got two show product details method, one in the parent, one in the child. So child method will be executed and not the parent method. So this fundamental over here is referred to as overriding. Very, very beautiful concept, guys. So overriding versus overloading. Method overloading, whereas this is method overriding. So same method name with same inputs in parent-child relationship. So only in a parent-child relationship. Now when you run this code here, what you see is the other details also coming in. Now we know the reason that why we need to overload a method, why we need to override a method. We need to overload a method so that we can write the exact data which we want. So we are customizing this method in the child. We are overriding the method so that we can display more data. So we are customizing the methods in the child, right? So overloading and overriding is what where we are having customizations to predefined methods. We don't want these predefined methods. We want the way we want to present the data and we have it in front of us. So this is a very quick introduction to object-oriented programming structure, guys. So now let us come here and understand the next part. So inheritance is where one object will acquire the properties of other object. It is a relationship, the parent-child relationship. So syntactically, you need to come up and say extends. So which is extension, right? What are the advantages? Code reusability. So we are reusing the code, having an extensibility. We are using overriding. We are even having the features to hide the data. If you privatize any attribute, you won't be able to inherit it. So we got different types of inheritance. So you got single level, multi-level, and hierarchical, where single level is one parent, one child, multi-level is parent to child to grandchild, and hierarchy is having one parent with more than one children. Multiple inheritance, that's opposite of hierarchy, is not supported in Java. So there is no virtual keyword, there is no pointer technique in Java by which we can solve the problems like dreaded diamond here. So in single level inheritance, we got one parent and we got one child. So arrow is upwards because B is an A, right? So it's extension relationship. Then we have multi-level, parent to child, child to grandchild. And thereafter, guys, we got hierarchy where one parent with the multiple children. So remember, we don't have support for multiple inheritance in Java. That's like the reverse of this hierarchy. Multiple parents having the same object. Next is polymorphism. So guys, it is having the same name with the different definitions. So you can say mothers, they are the best example of polymorphism. They handle kids, they handle office, they handle home. More than one form, right? So here polymorphism can happen in two different ways, compile time and runtime. So what is compile time versus runtime? So compile time means overloading. We call it static polymorphism. So compiler will ensure which method will be executed for which function call. So there are some rules to overload. The method name should be same and the argument list or the inputs to the method that should be different and unique. So the other form is runtime polymorphism. That's like dynamic polymorphism where we got method overriding. All right. So overriding, we got some rules coming in here. So the rules to override is where the method name should be same, input should be same, return type is something which must be same or the subtype of the overridden method. And access level, it must be same or more restrictive. Now, what is abstraction, guys? So abstraction is achieved using abstract classes and interfaces. So this is where we achieve a runtime polymorphism in a different approach, right? So here we have an abstract class. So an abstract class is created using an abstract keyword. So here we will have the methods with the abstract keyword. We even have non-abstract methods. This is a class for which you cannot create objects. You can have constructors, you can have static methods, but we cannot create the object, right? So you can even have the final methods. So abstract class acts as a template for the various methods and definitions to be executed. So moving ahead, so the better version of abstract class is an interface. So interface is a blueprint for a class which will contain some constants and abstract methods. So it will enable a multiple inheritance and helps in achieving the loose coupling. So a class can extend a class. A class implements an interface. Now this is one of the major differences between classes and interfaces. So we got interface to interface inheritance as well. So guys, abstract class and interfaces. So as in practically we'll see it in our other sessions. So lastly, what is encapsulation? Where we are going to privatize the data. So we can have an attribute, we can mark it as private, and when the attribute is marked as private, it cannot be accessed. So we need setters and getters so as to access this private data. So encapsulation leads to data hiding. So it is focusing on security. So this is all from my side and Edureka. So thank you so very much, guys. Have a wonderful time ahead. Once again, this is Ishant on behalf of Edureka. So in case you have enjoyed the session, so do review us, do subscribe to our YouTube channel, and do like our Facebook page. Thank you, guys. Bye-bye.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!